Okay, hello. Today in this lesson we're going to learn how to add and multiply polynomials. Adding, as we'll see, is very easy. You've already done this stuff. Multiplying is also not too hard, but we're also going to learn how to use special patterns to multiply. And then furthermore, we're going to be learning how to use Pascal's triangle to expand binomials. So adding and subtracting polynomials. The key thing here is just adding and subtracting the like terms, the terms that have the similar variable terms. So here we have two polynomials. We're going to identify the like polynomials, the x third term, the x squared term, the x term, followed by the constant term, and add all of those together. And you notice how I organize my work where I just underline them or have some sort of way of marking them, making sure I've kind of tracked them and taken care of them. In this case, we have another polynomial here, one polynomial subtracted by another polynomial. You know, oftentimes I see people thinking these are multiplication. Just because there's a parentheses here, people think multiplication, but you know, we have an addition sign right here, we have a subtraction sign right here, so that's the operation, adding and subtracting. But anyways, back to this. When we subtract here, subtracting a polynomial, we need to distribute this minus sign all the way across. So what we'll do here, what I like to do is just subtract or flip all the signs of every single term in here. And now I just go about adding each of the like terms one by one. So my x squared term, my xy term here and over here, my y squared term right there, and my constant term at the very end right there. Okay, so adding and subtracting is super easy. When we multiply polynomials, it's the same thing that we did when we had, you know, a plus b times c plus d type of thing. We're going to be multiplying every term by every term. So we're going to multiply the x times the entire polynomial over here. So that's the blue term of x times each one of these. We get this in blue. And then we take 3 times the whole thing over here as well, and we get another 3 terms. And once we have that, we just go about our adding of all the like terms. So we have our x cubed term, x squared term, x term, and constant term. When we have this kind of thing, a 3 term multiplied by a 3 term, same thing. I'm just going to show a slightly different way of organizing it. It's just a different way of doing it. Same idea. I take the x squared, multiply it times all 3 of these terms here, and I write it out. Notice now, when I take the negative 3x, I multiply it times each of these. As I'm doing it, I'm just organizing it underneath the like term. So here's an example. Minus 3x times 4x squared, that gets me negative 12x cubed. I'm going to line that right underneath the x cubed terms so that when I add them up later on, it makes it easy for me. Lastly, I have my 2 term here, multiplied times the entire polynomial. I write it out there. Now I'm just going to be adding all the polynomials together, and I can add them straight down now that I've organized it. As I was multiplying it out, I organized it in a way which makes it easy to add. Okay, so with the previous method here, you know, this is the way you multiply all sorts of polynomials. And if you had a polynomial like, you know, this a plus b, c plus d, e plus f, I would multiply these two together first, and I get a bigger polynomial, and then I would multiply after that. I would multiply this times that. So you can just continue on and you can multiply huge amounts of polynomials together. Now there are some shortcuts that we can do just to make our life a little faster. These are important. Sum and difference, this is a very important one. A minus b times a plus b. This is the difference of perfect squares, and this one you have to memorize. You should be able to go back and forth between this, either from this term here over to here, or the other way around from the right-hand side to the left-hand side. We've seen this already too. Square binomials, a plus b squared, a minus b squared as well. and these expand out to here. And again, it's very nice to be able to kind of see this and go back and forth between the two. A warning, very often people do this, a minus b quantity squared. They distribute, people accidentally distribute the squared sign to each of these pieces, kind of like they distribute multiplication over addition, but this, we cannot do this. You see here that there's an extra term right in here. Cubed binomial, same thing. This is not equal to a cubed plus b cubed. It's actually, if you were to multiply it all out, it expands into something like this or like this. And these, these are shown here. I'm going to show another way later on in another video using Pascal's triangle. These are really good to memorize. This is nice to know. There's a nice little expansion that we can have here. Okay, let's look at some examples of how it's applied. You see here a minus b, a plus b kind of structure. So we know that it's going to be equal to a squared minus b squared, where a is our 3x, b is our 4y. So we could kind of plug it into the template here and then go ahead to simplify. We have a square binomial here, a minus b quantity squared, and it kind of expands out into a squared minus 2ab plus b squared. So again, we have our a, we have our b, and we just plug it in here. So plug in the a and the b, plug in the b squared, and then simplify. You notice here, this squared term here, 3t squared, it's like 3t times 3t, which becomes 9t squared. And in this case, the 2 does kind of distribute to each of these terms because it's exponentiation over multiplication. And in that sense, there is kind of a distributive property there going on. Last one, mn plus 4 to the third power. This is our cubed binomial, and we use this template here, plugging in our a and our b. This simplifies out to this. So very useful shortcuts to learn. That's the lesson. Go ahead and do these problems. See, whether or not you can apply a shortcut to them. Some of them you can. I'm going to show the answers in 3, 2, 1. Okay, that's the end of this lesson.